Right now on the pad of your thumb, there's a pattern that no other human being who has ever lived has shared. Not your parents, not your identical twin if you have one, not one single person out of the 100 billion or so who have walked this planet before you. And here's the strange part. That pattern was locked in before you were even born, months before you took your first breath, and it will still be there, essentially unchanged, on the day you die. How does a few square centimeters of skin end up more unique than your DNA? And why, out of everything about your body that changes, your height, your face, your voice, did evolution decide that this one thing should stay frozen for life? Today we're going inside the biology of the fingerprint, one of the strangest, most quietly remarkable things about the human body. We'll trace it back to the womb, to the exact weeks these patterns first form. We'll look at why even identical twins, sharing the same genetic code, end up with completely different prints, and get the real answer for why, whether you're 7 or 70, the ridges on your fingertips stay put. By the end, you'll understand something most people carry with them every day without ever thinking about it. Fingerprints are made of tiny raised ridges of skin called friction ridges, found not just on your fingertips, but across your palms and the soles of your feet. Their basic job is exactly what the name suggests: friction. They help your hands grip objects, sense texture, and keep water from pooling under your fingers when they're wet, which is part of why prunish fingers may actually improve your grip in the rain or the bath. But it's the pattern those ridges form, the loops, whirls, and arches, that makes each print effectively one of a kind. Here's something that might surprise you. Humans have used fingerprints as a form of identification for thousands of years, pressing them into wet clay and wax to seal documents long before anyone understood the biology behind why the marks were unique. They just knew, instinctively, that no one else's print looked the same. To really understand why our own prints form the way they do, we have to go back to a moment most of us never think about: before birth, inside the womb. Somewhere around the 10th to 16th week of pregnancy, a developing fetus starts growing small mounds of tissue on the fingertips, called volar pads. As the hand keeps growing, but the pads stop growing at the same rate, the skin on top begins to buckle, layers under the surface folding, almost like fabric bunching up as it's pushed from underneath. Those folds become the ridges, and once they form, they're not just sitting on the surface of the skin. They're built into a deeper layer, one that regenerates the exact same pattern even after the outer skin is scraped, burned, or worn away. That's the first big clue as to why fingerprints last a lifetime. They're not printed on you, they're printed into you. Here's where it gets strange. Genetics clearly plays a role. Researchers have identified genes involved in ridge growth, including genes tied to limb development. So you'd expect identical twins to end up with matching prints. They don't. Identical twins share nearly identical DNA, yet their fingerprints are different enough that forensic experts can always tell them apart. If it isn't purely genetics, something else must be steering the pattern, and that something turns out to be almost accidental. Inside the womb, a developing fetus is bathed in amniotic fluid and pressed gently against the walls of the uterus, the umbilical cord, and even its own body. As the volar pads swell and the ridges start to form, tiny random differences, the exact pressure of a finger against the amniotic sac, the rate a particular pad grows, the position of the hand in that cramped, shifting environment, all nudge the ridge pattern in slightly different directions. Scientists call this developmental noise, the biological version of chaos, where the same instructions can produce different results depending on tiny, unrepeatable conditions. That's why even two fetuses with matching genetic blueprints, growing side by side in the same womb, come out with different prints. Your fingerprints are a product of that one specific, unrepeatable window of your existence when those ridges were folding into place. And once that pattern locks in, something remarkable happens. It stays. Not just similar, but the same. As a baby grows into a toddler, then a teenager, then an adult, the hand gets bigger and the print scales up right along with it, the same way a photograph gets larger when you zoom in. But the ridge pattern itself, the sequence of loops and whirls, the way they branch and end, doesn't rearrange. It's the same map, just printed on a bigger piece of paper. This is the opposite of how most of the body works. Your face reshapes with age, your skin loses elasticity, your hair changes color or disappears. But this one specific pattern on your fingertips is, for almost everyone, essentially permanent from before birth until death. That permanence is exactly why fingerprinting became one of the most trusted tools in criminal investigation and identity verification. Because the pattern is set so early and stays so stable, a print print taken from a person as an adult can be compared to one lifted decades earlier and still line up. Law enforcement agencies have relied on this fact for a century, ever since fingerprint identification began replacing older methods like measuring skull and bone dimensions, which proved too unreliable. By the late 1800s, scientists had confirmed fingerprints stayed the same for life and were never duplicated, and police departments worldwide adopted fingerprint filing soon after. But permanence isn't the same as indestructibility. Surface-level cuts, burns, or scrapes heal and the ridge pattern grows right back. Because, remember, the blueprint lives in that deeper layer of skin, not just on top of it. It's only when an injury destroys that lower layer entirely, leaving a genuine scar, that a fingerprint can be permanently altered in that one spot. Manual laborers who work constantly with abrasive materials can wear ridges thinner over time, and rare genetic disorders, documented in only a handful of families, can mean someone is born with no fingerprints at all. Which brings us to the deepest layer of this story. For over 100 years, forensic science treated the fingerprint almost like magic, a perfect signature nature happened to give every human being. But only in the last few years have researchers started mapping which genes are responsible. In 2023, a large-scale genetic study identified specific genes, including one called EVI1, that help shape whether a person's ridges form loops, whorls, or arches, the same family of genes involved in growing fingers and limbs the first place. That finding hints at something almost poetic. Your fingerprints may exist not because evolution needed you to have a unique identifier, but as a biological byproduct, a side effect of the same genetic machinery that built your hands, shaped slightly differently each time by the unrepeatable chaos of development in the womb. Nature wasn't trying to give you a signature. It gave you one anyway, purely by accident. That's the real answer to why your fingerprints never change. They're not a decoration added on to your finished body. They're quite literally structural, folded into a living layer of your skin during a narrow window before birth, shaped by a mix of genetic instruction and pure chance that will never happen in exactly the same way for anyone, ever. That same permanence is why fingerprints quietly run so much of modern life. Every phone that unlocks with a touch, every passport verified at a border, leans on the exact same biological fact this video has been building towards, a pattern set once in the womb that neither time nor technology has found a way around. So the next time you unlock your phone with a touch or press your thumb onto an ink pad, consider what you're looking at. It's not just a whirl of skin, it's a physical record of a few chaotic weeks before you were born, a pattern shaped by pressure, position, and pure chance, then locked into the deepest layer of your skin for the rest of your life. Billions of people have existed on this planet. Not one of them has ever had your exact fingerprint. And after everything, the growing, the aging, the decades that reshape almost everything else about you, that one pattern was already finished before you ever took a single breath.